All right, welcome back. We're going to do some more statistics. This is section 3.2. This is going to be part two. So we are doing measures of spread here. We're doing standard deviation. We're doing a lot of calculator exercises with this. Okay, so hopefully this helps you guys walk through your homework. If not, that's okay. Let me know. I can do something different, but you're not required to watch these. Okay, so if you were in my class, this helps. That's great. If not, feel free to disregard. Okay. So we have a recent survey of 655 working Americans. Weekly average amount spent on lunch was this amount. We have a standard deviation. We have a weekly amount that's approximately bell-shaped. That's important to know because what they're going to ask us to do is use the empirical rule to estimate some probabilities. Okay, so just bear with me just a second here. So we're going to talk a little bit about empirical rule. Okay, there we go. Empirical rule. I don't usually want anybody to memorize formulas, but in this case is an exception. Okay, you must memorize the empirical rule. So if you have a bell-shaped distribution, so if bell-shaped, okay, there's about 68% of the data is within one standard deviation of the mean of the center. Okay, 68%. You say that's kind of weird. Like there's a reason they came up with these specific numbers. Even though you're supposed to estimate it, then that's how we're going to figure that out. Okay, then we have 95% is within, that could be plus or minus, by the way, so within two standard deviations of the mean. Okay, and the last one, it kind of depends on book to book. Some books use a little bit different, but I think our book uses 99.7% is within three standard deviations of whatever the mean is. Okay, and I'm looking at these numbers and I'm thinking to myself, I can't estimate that based off of what we have here. So when I go back up and read the problem, okay, we have 655 working Americans aged 18 to 35. Okay, you think all these things were important, but they're not. Average weekly spend on lunch is $42.35. We're going to write that down over here. So we have $42. So the average amount or mean, depending. Okay, if it's a statistic, if it's it's a parameter, if it's a population value, it's going to be using this. If it's a statistic, we're going to be using that. So we're going to go ahead and say we want average weekly amount spent on lunch, $42.35. Okay, $42.35. We're going to assume this is for, I think we're going to assume this is for a mean. I think that's the way they want us to do the problem. And then they come up with standard deviation. Okay, remember this is a little sigma. Okay, so Greek letter S. So the standard deviation is going to be $2.94. Okay, $2.94. Notice I made the assumption that this was a population, even though technically this is a sample, but this is kind of one of those things where if it's in this chapter, they generally want us to use the sigma because they want us to use the Z formula. So they were going to calculate Z scores. I'm going to say X bar or X rather minus mu divided by sigma. That's generally what they want to do. And this is a little bit beyond where this book is. So if you're not getting this, that's okay. You want X minus X bar divided by S. That's the sample standard deviation, okay, rather than the population. That's technically a t-score rather than a z-score, but I think they only introduced you z-scores. So if you're looking at this like I never heard of anything, if I heard the z-score, okay, but if you haven't gone on to do t-scores, you're not there yet, that's okay. You can safely ignore this. This is where they want you to be. Okay, this is the part they want you to be able to deal with. Okay, so all we have to do is figure out, like, well, how many standard deviations away is this? And that's what z-scores tell us, is how many standard deviations away. So I'm looking at these numbers and, like, I can't tell just based off of, like, looking at it to know. Some of you guys can, okay? But right now, like, I'm not going to be able to tell. So I want $33. Okay, let's go ahead and move this out of the way because I want $33 and 53 cents minus, what was my average? Okay, my average was $42 and 35 cents. And then we're going to divide it by this $2.94. Okay, usually in this chapter, they're trying to be symmetric. So if we get one, we could probably get the other one. But just to be safe, let's go ahead and do the other side. So $51.17. So we want $51.17 minus $42.35. Okay, that's still the same average. And then divided by $2.94. And then what do these equal? Okay, what do these equal? So we'll go ahead and just calculate that. So we're going to say this is going to be, this is careful, okay? Be careful about this. So we're going to say $33. Oh, I don't want sort, I just want just clear everything here. Thank you. $33.53, okay, minus $42.35. Okay. And then we're going to divide this by $2.94. So this is 2.94. Okay, this tells you how many standard deviations away. This is minus 3 standard deviations down. Okay, so these people paid a lot less money for lunch than their average counterparts here, okay? So we'll go ahead and we'll check the other side. I'm going to guess it's going to be positive 3. It doesn't have to be, but that is generally what they do to you in this part of the chapter is they keep them symmetric. So this is minus $42.35 equals, okay, and then divided by $2.94. Right? We got a positive 3. Go figure. So we are between, okay, what they're explaining is between positive 3 and negative 3 standard deviations from the mean. These are the people that paid, and almost everybody did that. So it's 99.7% of the people spent between $3.53 for lunch and $5.17 for lunch. Okay, given that the average is $42 and that the standard deviation is $2.94. Okay, so 99.7% of the people spent between these two amounts for lunch. So we're going to say approximately, I want almost all. Almost all. Okay, so they don't tell you the value, they're going to say almost all. So that's what they're going to check here. Okay, so they want almost everybody. So hooray. Okay, estimate the percentages that did this one. So all we're going to do is the same idea here. Okay, we're just going to use z-score. So we're going to say, okay, I need $36.47 minus, what was that average again? Okay, the average is $42.35. $42.35 divided by $2.94. Okay, and I will check the other side. Okay, and again, it's probably going to be the opposite, but it doesn't have to be. So we're going to double check and make sure that that's what's going on. So $48.23 minus $42.35. Okay, and divided by $2.94. Okay, so where I got those numbers, right? They told me. Okay, $2.94, average $42.35. Okay, so all we're going to do is we're just going to plug those in. Okay, and I'm being real careful about that. If you want to use parentheses, that's fine. I like to do $36 minus, or I'm sorry, 36.47 minus $42.35. And I'm just going to hit equals because I just want this top part divided by $2.94, 2.94. Okay. Now you only have this for one standard deviation in the mean, 2 standard deviations within the mean, and 3 standard deviations within the mean. We will get to more complicated examples when we get to chapter 7. But right now, if it's not 1, 2, or 3, I think you've done something wrong. Okay. So this is going to be 48.23. So 48.23. We have a point, like 23 minus, and then we have 42.35. It equals divided by $2.94, 2.94 equals, we have positive 2. So this is within, right? We have 2 standard deviations down from the average, 2 standard deviations above the average. So that is going back to our rule that it's 95% of the data should fall between minus 2 standard deviations, and positive 2 standard deviations, okay? So we're going to check, we're going to say choose one, we're going to say, oh, that's about 95%. Okay, so we'll check and get our check mark and say hooray, and then they want to know what values between 2 standard deviations, or between what 2 values will 68% of the standard deviations be, okay? So 68%, right, is within 1 standard deviation. Okay, so let's go ahead. We're gonna do this out a little bit analytically. So we're gonna say x minus mu divided by sigma. And what we want to do is we want to say this equals -1. We want to do 2 problems. So x minus mu divided by sigma is equal to +1. If you have escaped intermediate algebra or you're in college algebra and you remember absolute values, that's what we're doing. Okay. And now we're going to do is we're going to solve for x. Okay, so we're going to solve for x here. We have 2 problems to go with. So the first thing I'm going to do here is like, well, how do we get rid of the fraction? What we're going to do is we're going to take our x minus mu divided by sigma equals -1. We're going to multiply both sides by sigma on both sides. Okay, so that'll cancel this. We have x minus mu equals minus sigma. And then what we're going to do, we're solving for x. So we're going to add the average to both sides. We'll add the average to both sides. So we have x equals mu minus sigma. Okay. If I go on this side, if I do it the +1, okay, then we're going to have the same idea. We're going to have x minus mu, right, over sigma equals 1. So we're going to say x minus mu divided by sigma is equal to 1. Right? Remember, this is the average, this is the standard deviation. It's the little sigma. I write mine like a sideways 6, and then this is mu. Okay, so we're going to multiply both sides by standard deviation. That cancels. Okay, so we have x minus mu is equal to sigma, and then we're going to add both sides. We're going to say, well, let's add mu to both sides. So plus mu plus mu. So we have x is equal to mu plus sigma. And that is going to give us the values that are within 1 standard deviation. Right. So we have to go back to the problem and say, well, what the heck was the average, right? So the bottom one is going to be the minus. So we have x equals mu minus sigma. What was our average, right? Go back up here and we'll say our average. We have to go back and look. Okay. So they wanted $43.35. Okay, so this is $43.35. And we're going to subtract off $2.94. Okay, so let's go ahead and do that in our calculator. So we have $43.35 minus $2.94. Right? Oops, nope, I don't want that. So let's delete that. Hit enter instead. So I want $40.41. Okay. And then on the other hand, we're going to add, right? So we're going to have $43. Okay, so we have $43.35. We're going to add $2.94. Okay, so we'll go to our calculators and do that because I'm not going to be good enough to do that today. So $43.35. I probably should. Okay, plus $2.94 rather than rely on a calculator, but that's okay. You guys can use calculator. There's no shame in that. I'm not going to know. I'm not going to say anything to you. I'm using the calculator. So $46 and what do we have here? And 29 cents. 29 cents. Okay, so 68%. That's within -1 standard deviation, +1 standard deviation. All right, so that's all we're going to do is we're just going to type that in. We're going to say, oh, that must fall between. What's the first number I have here? I have $40.41. $40.48. I think that's the number I had. $40.41 and then 42.29. 42.29. And we'll do our fingers crossed to make sure that that happened. And it didn't like either one of those. One of your digits is wrong. Work more carefully. Oh, $46.29. Ah, there we go. Double check that. $46.29. Okay, we'll try that one. So they were draconian and just marking the whole thing. They really did not like this. Oh, that's because I didn't type it in correctly. Okay. I want 46.29. Okay, we'll check one last time. Fingers crossed. Did not like. Okay, one of your digits is wrong. Work more carefully. So I'm just going to double check $43.35 plus $2.94. Make sure I have that written down correctly. $43, 46.29. Okay, and then 40.41. Okay. Oh, okay. I must not have done this one correctly, so we should double check. So we have $43.35 minus $2.94. Did I not do that right? Okay, so I know where they got the number. That's where it is. That's okay. All right, so we'll continue on because we're close. We know what mistake we made. We didn't type in the numbers into the calculator right, so it's not a mistake we're trying to deal with. Okay, so let's see if we can do. So we went approximately. Okay, so it's effectively the same problem. Okay, we went between what two values? Approximately 95% of the number of days before a bill gets paid. Okay, so utility company, we went 28 as an average with a standard deviation of 3 days. Assume that this is approximately bell shaped. Okay, that's what we need. So we're going to go back here. Okay, and I'll go ahead and say, well, what is our average, right? I'll go ahead and do it in the middle here. So we want our average, right? X bar is going to be, let's see if we can get through this one correctly. So we have 28 days, standard deviation of 3 days. 28. Standard deviation is 3. So we want between 95%. Okay, so we're going to say, oh, that's between -2 and +2. So what we have to do is we have to say x minus mu divided by sigma equals -2. X minus mu is divided by sigma is equal to +2. Okay, all we're going to do is we're just going to type in the same idea here. Okay, so I notice a lot of people would rather do this with numbers. That's fine. So we're going to say x minus 28 divided by 3 is equal to -2. X minus 28 divided by 3 is equal to +2. So in order to solve for the x, that's the number of days that we want. Okay, x is equal to the number of days. We're going to multiply both sides by 3. So that's going to cancel. So we have x minus 28 equals 2 times 3. That's going to be 6. Okay, same thing here. We're going to multiply both sides by 3. So we have x minus 28 is equal to 2 times 3. That's going to be 6. But remember that 2 is a negative, so it's -6. And then we're just going to add 26 on both, so 28 on both sides. Add 28. Okay, add 28. So it's 28 minus 6. I think that's 22. Okay, so it's going to be between 22 days. And then that's going to be x equals 6 plus that. That looks like it's going to be 34 to me. Okay, so 26 to 34 days. I like this problem a little bit more. There's fewer decimals, there's fewer digits. So we'll go ahead and check that. So that's going to be 26 to 34. 26. How about 26? Okay, 26 to 34. Okay, we've got 34 days. Okay, and we'll go ahead and so are we allowed to check? We double check here. All right. I don't want to do that. Where are we as far as that goes? Just type in return. Hopefully that'll work. No, it didn't like it. I think we're going to have to go down a little bit so I can scroll. Oh, there we go. Check. Okay. Fingers crossed. Try again. Did not like it. So we're going to double check our arithmetic here. I'm so sorry about this. So X, do we write down the right values here? Okay, 28 days. So average payment, sent out 28 days, standard deviation 3. Okay, so let's check. Okay, so 95% is within -2 and +2. So 2 times 3, -6. -6 plus 28. That should be 22. Did I just not write it down right? I didn't write it down right. But 22. Recheck. Fingers are crossed. Okay, that's much better. Now that I got my arithmetic right and I transposed it correctly. See, that's why math teachers want you to share your work. So I feel bad for you guys because you're going to get quizzes like this. So if I see that mistake, I tend to circle it and then not really take that many points off. But clearly, we're going to be doing this in ALEKS, so they're going to take more points. So you have to be more careful. Okay, but that's why we want you to show your work, is because I don't want to dock you for mistakes like that. Okay, everybody can make a changing a 22 to a 26 when you go from one paper to another. Everybody can make that mistake. So I wouldn't feel too bad about that. All right. So we'll go ahead and check. Okay. Okay, 25 and 31. So that's a similar problem. We're going back to what we did before. So we want to go 25 to 31. Did we just? No, we didn't. We didn't just do this. So what we're going to do is we're going to check to see how many standard deviations away are we. Okay. So again, we have the same scenario. So the average, right, that was still 28. The standard deviation, that was still 3. Okay, that's the same scenario that we had from before. And they want to know approximately what numbers are between, okay, 25 and 31. So what we're going to do is we're going to say 25 and 31. So we want 25 minus 28 divided by 3. 25 minus 31 divided by 3. Right? Because I wanted, no, wrong one. We want, yeah, that was right. 31 minus 28 divided by 3. That's what I want. Okay. So 25 minus 28, that's minus 3. Divided by 3, 3 over -3 is -1. Okay, this is going to make 3, so this is 3 over 3. That's a positive 1. So what percentage of the data was within one standard deviation of the mean, between -1 and +1? That was 68%. So we go back to our ALEKS here. So we're going to say 68%, approximately, I want 68%. Okay, check. Hooray. All right, and that's pretty much what we're doing with all of these. Okay, we're going to check both of this. We're going to check 19 and 37 and make sure that we have both of those numbers correct. Okay, so we're going to go ahead and check that. All right, so what is, I lost it. So we want 19 and 37. Okay, so we want 19 days minus, what was my average? Okay, it was 21, 28 rather, divided by 3. So what is 19 minus 28, right? It strikes me like that should be 9. Right, so 19 minus 28, okay, equals, and then divided by 3. So this is equals -9 divided by 3. So that's going to be -3. Right? This is the other value they wanted. Okay, it's probably going to be the same on the other side, but we're going to double check. Okay, so it's probably going to be the same, but we're going to double check to make sure. So we're going to say, oh, sorry, that it's going to be 37. Okay, so we're going to go ahead and hit 37. So we have 37 minus 28 divided by 3. Unfortunately, this is x minus mu divided by sigma. That is a formula you do have to memorize. Okay, we could chat about what could be on formula for the thing, but I've not set up quizzes in ALEKS yet, so I don't know how much freedom I have. So I would say, you know what? We're going to memorize this. It's not too bad. If you do enough problems, you'll memorize. So 37 minus 28, that should be 9. 9 divided by 3. Okay, and 9 divided by 3 is going to be that. So we have to memorize a little bit in this section So we went -3 to +3. That was almost all, right? That was 99.7%. Let's see what options they give us here. So we'll go back to Alex and we'll say, I want almost all. Okay, that's what they're wanting to say. All right. Check that one. That looks pretty good. And then we can move on to the next one. Okay, so we'll just say continue. Okay. So let's see. We're going to compute the coefficient of variation for the exam scores. Okay. So actually, I'm going to pause this. I'm going to go with part 3. So we'll go ahead and stop.